Welcome to this CRe-AM presentation on its road mapping strategy, presented by Carl Smith and myself, Rasool, from Ravensbourne Learning and Technology Research Centre in London. The strategy was built by gathering expert opinion, initially from the architecture sector, where experts were asked about the current situation and also the future situation using specific questions which were then numerically weighted and analysed to predict strong and weak signals as well as emerging trends. It was peer-reviewed by Varna Kantzer from Brunel University, and she looked at some of the factors that made it novel compared to existing S-shaped roadmap that may have been used. Amongst some of the benefits that were seen was that it's possible to see what's being undermined in the industry sector as well as what's being promoted, and do things such as explore what-if scenarios and simulations, and recognise that the maths behind it is simple enough to be explored in Excel like spreadsheet. Most importantly, the roadmap's building blocks are based on the weights of importance industry experts place on specific technologies being used with specific techniques, and that allows for emerging mindsets and current mindsets to be visually seen. The overall advantage was that it did allow for cross-impact analysis with other technologies which are needed to be co-developed, but there are limitations. It needs to be discussed, and there are sectors such as design that don't have any clear hierarchy that might need to use different maths in order for them to be analysed. We did consult a lot of experts, amongst them people like Theodore, who's director at Minima Forms in AA London. He links architecture with technology, relying on interactive and evolutionary process to achieve the creation of atmospheres that actually alter perception of the awareness of space. We also had a chat with Sean Hicks from Levitt Bernstein, who's senior project leader of BIM development there. He's a BIM champion and tasked with the ongoing development of BIM processes within the office there, but he's also co-founder of BIMnet, established in 2012. Carlo Ratti from Sensible City Lab at MIT, he's the director there, was interviewed. He's well known for being on the smart list for 50 people who'll change the world, and he's named inaugural innovator in residence by the Queensland government. The road mapping strategy for CRe-AM is actually based on three component roadmap archetypes: the emerging paradigm model, the technology trends model, and a new roadmap specifically created for CRe-AM, the signals matrix. The emerging paradigm model actually recognizes that knowledge and practice and associated technology move and develop through three key stages. There's a new way of thinking that emerges, a new mindset. The mindset's then put into action and practice through various techniques, and lastly those practices are refined and scaled up and disseminated using technology, and if that's done well enough, it then further refines new mindsets and develops new ways of thinking. The technology trends roadmap asks questions about what's going on in the industry, what's going on for customers and what's important for them, how do people get leverage from an emerging trend, as well as how is it possible to prevent threats that might come up from that trend in terms of risk mitigation. It's possible to take the answers and numerically weigh them up and see how big the importance of these particular trends are for the short term, in the immediate present, for the near future, in terms of the imminent future, and lastly for the foreseeable future, to see what long-term developments there might be. The technology trends can be constructed by asking the right questions and then finding a way of numerically weighting them and doing analysis on them based on what the implications are for the trend, what leverage is there for the trend, and what threats are there that need to be observed and addressed. Mapping factors that are driving trends can help construct roadmaps that illustrate what the industry is focused on, what changes are likely to be taking place, and identifying the consequent benefits and risks. So some of the things that can be explored are what's in the media, what analysts are talking about, what does the trend mean for professionals, which tools are going to become obsolete, how can there be leverage employed for a given trend, and can it be shaped, and can the trend negatively impact the core practice of what it is that a particular firm might be involved with. The influences in technology trends can easily be seen if they're laid out according to their implications, their leverage, and the risk mitigation associated with them. For example, 3D scanning can improve modelling, but it needs to be managed with interoperable file formats. Cheaper 3D printing can lead to quicker mock-ups, but you don't want to have too many revisions and nothing ever gets completed. And BIM convergence, for example, really lends itself to sustainability, but it will require support through exploration and research. Expert opinion was gathered and turned into numerical weights by assigning a point for every reference to a technique or technology, 3 points for every technique and technology that was associated with one another, and lastly 5 points for where emphasis was given to a particular area as being important for the industry. The signals matrix roadmap has been built from the frequency responses to the questions asked of experts and organised in terms of techniques and practices against the technologies that are used in those techniques and practices. The axes are organised in order of increasing complexity or scale or likelihood of it being used in the immediate present or the long-term future. Key themes were discovered amongst the techniques, including modelling, visualization, production, CPD, communication, collaboration and convergence. And in technologies, CAD, BIM, 3D printing, 3D scanning, virtual reality and robotics were the key themes. These are not necessarily final. Obviously, as we get more opinions, we're going to actually discover there are additional key themes, and we'll adjust the signals matrix as they come in. Now, despite appearances, the signals matrix is not two-dimensional. Because of the way that the individual areas relate to each other, it's possible to see how they might progress in the future. Very much like architecture, where you can see that it's static when you're looking at it, but over time the net forces might lead to that building subsiding. For example, if the foundations aren't strong or the integrity of the building is questionable because of the materials that we use to put it together. If you look at the sample data set, we can see straight away that the area that's come up strongest is the area of drafting and CAD, and how people are trying to develop collaboration and communication in it. The two strongest scores on the chart are there at 52 and 48. It's possible to also identify strengths and weaknesses by looking at what the surrounding scores are around a cell. For example, in this you can see that communication's got a quite strong score of 52, which is a good foundation for the lighter score above it of 48. So in CAD, collaboration is something that's being well supported by underlying communication. However, in the area of virtual reality, although there's support for it with a larger score underneath it in the area of CPD, there's a bigger score above it, and that bigger score is putting pressure and weight on the CPD area, implying that if virtual reality and CPD in it isn't improved, it could undermine future communications around virtual reality. If we were to add up all the overall pressures and supports for each area in the matrix, we'd end up with a picture like this, and we'd clearly be able to see where there were groups of supported areas. There will be strong trends supporting those territories, such as convergence and collaboration that you can see here, but it also identifies negative trends such as communication and CPD here, which unless they're supported, it could lead to the undermining of the areas that are being promoted around collaboration and convergence. If we compare the overall support and pressure for each area with the original scores, it's possible to get a normalized view of the forces in proportion to what the original scores were. And here you can see very clearly that the area of 3D scanning and convergence is the most strongly supported when everything's normalized, and the area that's most weakly supported is actually 3D scanning around CPD. So with this approach, it's not easy necessarily to see what the center of a trend is, but that can be done by adding all the scores around a particular cell together with a value in that cell to get us a picture of where the center of gravity is for a particular trend, which we can see in the next chart. Here you can see that when the scores are added up and rounded, that the areas that got the biggest scores will be typically at the center of the trends in their area. So 3D printing and 3D scanning, for example, are at the center of a trend on convergence, that whole row of green. And you can also see that 3D printing and 3D scanning are also at the center of a trend to do with CPD, where ongoing support seems to be denied to that area. So it's possible to see exactly what the centre of the trend is. And it's possible that it might be considered to be a mega trend. For example, 3D scanning and convergence could be considered to be a big trend all in itself. If we organise the scores into groups of high scores, mid scores and lowest scores, we can get an idea of what might be important to the industry immediately, in the near future, and also in the far future, with a chart that can be used for the basis of an overview. The overview can be provided by the Three Horizons chart, which gives us information about how things are going to develop in the current arena, in the imminent future, as well as in the foreseeable future. So it looks at 3 time horizons. So if we take that data that we've had and we put it onto that chart, we can clearly see that in the current arena, the things that are really important are convergence, collaboration, visualization, BIM and 3D printing. In the near future, it looks like modeling, production, 3D scanning, virtual reality are going to be important, and the far future, communication and CAD. CAD seems a bit odd, but then if people are doing really well with that at the moment and don't need much improvement, it might not really need to be evolved until the long-term future. It's also possible to look at the underlying trends and how they link specifically with techniques and technologies. And you can see in the current arena there are trends relating to convergence and collaboration in terms of techniques, but we also see trends relating to tools and visualization, BIM and 3D printing. In the near future, the trends are very much looking at how modeling, 3D scanning and virtual reality might be trends to do with tools, and production area of techniques is going to be important for interdisciplinary collaboration. The long-term future, it looks like interdisciplinary collaboration is going to be necessary to improve communication and improve how CAD is actually worked with, and these are the areas that are probably going to need some resource investment in order to prevent them undermining the rest of the industry. Thank you for your attention, and if you'd like to contribute to the CRe-AM road mapping program and offer your opinion and contribute to the data, then please contact Carl Smith at csmith.rave.ac.uk or Jazz Rasool at j.rasool@rave.ac.uk. Thank you.